All right, so this is still lesson set 26. It looks like I missed a few problems. Nothing new there, just as absent-minded as can be. So some trig, an equation, a couple of graphs, looking at the period of some trig functions. 5 quick problems here. These are the problems I missed. Solve for the unit circle. 2 cosine x minus 1 equals 0. Cosine in the unit circle is measuring width. The maximum width we get is on the right at x equals 0 of 1, and the minimum is what we get on the left from 0 on the number line minus 1 at pi, 3.14. Radius lengths, one radius length is about 57.3 degrees. I want to keep mentioning that because that is one of the sticking points to understanding trig, is understanding radians. All right, so let's look at the unit circle. Let's get a little circle going here. Hey, not too bad for a rotator, a little problem rotator here. So there's our x, y. So if this is 1, that's about halfway. And so instead of going from the circumference down, I'll go up there and also that down. And it looks like that's about a half. Yeah. And that happens at, pause the video, this is the second time through, pi over 3, 60-degree triangle. That's 30 degrees. Opposite 30 is half the hypotenuse. And the other side is that length times root 3. And that's going to be on the SATs for you. So I'm mentioning it that way right now. So if all of a sudden this was 10 units, then this would be 5. And this would be 5 root 3. All right, so we'll be asking that question in a very short period of time. I'll be adding that to the lesson set so that you can do a little better on your SATs. So let's get rid of this. So that's a chunk of 3, that's 2, that's 3, here's 4, 5 pi over 3. At 300 degrees, I get this triangle, 90-degree triangle, hypotenuse is still 1. Sine is now negative root 3 over 2, but we were looking for cosine, which is this width, which was a half for both triangles. Cosine starts at 0 at a max. That's the max right there at 1. 1 period brings you back to 1. And we were looking for 1/2. That happened here at 60 degrees. And it also happened here at 300 degrees. Pi over 3, that x value, 5 pi over 3. That x value, 5 times roughly 1.05. Just to get a sense of how many radius lengths. Here's 1 radius length, which is less than 60 degrees. 2 radius lengths, less than 120, so I would have been there. 3 takes me here. 3.14 takes me there. 4.71 takes me to 270. And we're at about 5.25. Right there. Just trying to get a feel. All right, just some approximate feels for radius length. All right, so the next question was, what's the period of the function? I wrote it down over there. So y equals 10 sine x over 3 plus 2. All right, so what are you multiplying x by? If you know what you're multiplying x by in these parentheses, then you have the period at your fingertips. A lot of students have trouble seeing that x divided by 3 is 1/3 times x. Whatever that multiplier is, if you divide it into 2 pi, then you have an equivalency. Okay, 1/3 to 2 pi is 6 pi. So that's the period of this function. Now, how do we get the period of the function? What's not the shortcut is the start of your walk around the circumference is you haven't walked at all. And the finish is you've gone 2 pi radius lengths. Okay, I can see now where 6 pi comes from. So where does this function start? It starts at 0. What is the sign at that location? Well, it's the midline. 0. Sine function goes up to 1, goes down to -1, so I'm in the middle. As I walk around the first 90 degrees of the circumference, heights go up. So this, let's get our domain and range going here. One period, that's all I'm after. 2 is the midline, up 10, 12, minus 8, there's your range, -8 to 12. First 90 goes up, back to the midline, coming back. And where did I start? 0 gets me 2. Where did I finish? 6 pi gets me 2. And everything else is symmetric. So 3 pi gets you 2. 3 pi gets you 2, which means 3 pi over 2 should get us 12. Let's put 3 pi over 2 there. 3 pi over 2. Well, what happens to the 3's? They cancel. Pi over 2, straight up. Maximum of 1. 1 times 10, 10 plus 2, 12. Hopefully you're beginning to see that. All right, so the next one. 2 more. 1 more graph, 1 more period. So let's see if you can get the period of this function. Y equals 10, cosine 2x minus 6. This governs the rate at which I walk around the circle and where I start. All right, plus 2. Okay, I've kept that the same. Don't have to consider that right now. 2, -8, same range. That's a sinusoid. So now, what's the period? Well, what are you multiplying x by? Sure looks like the number 2. If I take that and divide it into 2 pi, pi units. All right, so pi units. If I just can figure out where I start. Oh, 2x minus 6 equals 0. I think I'm starting at 3. Oh, it's a cosine function. Here, 1 period. 3 gets me 0. The cosine is 0. Is the width at that place on the unit circle, which is a maximum width on the right. All right, and I talked about that on problem 1. So 3, and now I know where I finish. Same place before I start to repeat. That's 1 period. And I know that that distance right there is what is called a period, that distance, and I now know it is 2 into 2 pi is pi units. So if I'm starting at 3, then my end of my first revolution is pi plus 3. Well, let's see how that works. Let's put pi plus 3 in here. Pi plus 3, excuse me. And let's do minus 6, I believe is what it was, plus 2. Okay, I think I've got the right amount. So what does that become? That becomes 2 pi plus 6 minus 6 plus 2 cosine. Oh, the 6's cancel. Cosine of 2 pi, the end of the revolution right there. Okay, I went around. Oh, I'm back to a maximum width. Maximum width of 12. That means 3 plus pi over 2, that's half of that distance, puts me right there at, what did I say, -8. -8 to 12. So that's going to get me -8. Let's actually see if it does. 2 times 3 plus pi over 2. Oh, the 2's cancel. The 6's cancel. It looks like I'm at pi, and pi is over here. Oh, that's a -1 for a width. Minus 10 plus 2. Minus 8. Okay, so that's the graph. That's the period, because why? Because as soon as you're here, you start to repeat. That's a repetition. Right, there's 1 period right there. All right, so that takes care of those 5 problems. My apologies, it should have been with the first video, but I don't want to miss out on 4 days in a row, because I think 4 days in a row, you can learn a lot of problems, not just one topic, not just 2 topics that you practice for 20 times and then you move to something else. And every time you move away from working on something, slipping away. And it's all about recall. Best way to recall something, talk about it every day, even if it's just for a minute or 2. All right, so let's see, we'll add that. Stay safe and warm. And I got backup.